the heavier you get. So let us prove this physics fact, which says that the faster you move, the heavier you get. So our proof starts from Einstein equation. Einstein equation, which says that E is equal to mass times c square. So where E is energy and m is relativistic mass and c, this is the speed of light. Let us say this is equation 1. Now for the moving object, this equation modifies. We have the new equation for the moving object, which is E, or energy square, equal to rest mass of object, which is m naught c square, plus momentum of the moving object times c, like this. So now by combining this equation, we found that substitute here E. Our E here is mc, so to be mc square equal to m naught square c4 plus t square c4. Now here there's no square here. It is momentum times speed of light. So if we square here to be p square c square. So now here we find that there is m square c square more c4 expand 4 equal to rest mass m naught square c4 plus momentum of moving object times speed of light is c square. Now let us divide by c, c4 both sides. Here to be c4 and here c4. So our relativistic mass will be m square is equal to m naught square plus t square c square. Now if you root here to find the relativistic mass, to be mass is equal to m naught square plus p square plus c square. So this is the relativistic mass, but the momentum of moving object is given by mass times velocity. So we have to substitute here mass m naught square plus m. Now our momentum is mv, to be m square v square over c square. Okay. Now if we square both sides, find that we have m square is equal to m naught square, which is resting mass, plus the relativistic mass m square v square c square. See, here there is relativistic mass and here relativistic mass. Now let us bring here this side. So m square minus m square v square over c square is equal to m naught square. So here m square to be 1 minus v square c square is equal to m naught square, divided by this one both sides. 1 minus v square c square. So divide by 1 minus v square both sides. So this one So it will be m square is equal to m naught square minus v square c square. The root both sides, so m will be equal to m naught over 1 minus v square over c square over c square. So this is a relativistic mass. So we found that here, if v increases to this formula, if v increases, it means this value here will be small, because we have to minus by 1 and then root, so it will be small. When you divide m naught divided by 0 point, as the smallest amount here, it will give the bigger mass here. Also, if we say that, let's say for the object moving in a speed of light, it means here m will be equal to m naught 1 minus v over v square. So here it will be equal to 1 minus 1. M naught is equal to 1 minus 1, which is 0. So 0 m naught divided by 0 to give you, say, infinity. So the mass will be greater when the object moves with speed of light. So we confirm that the faster you move, the heavier you get. The faster you move, the heavier you get.